Okay, let's finish off the review questions. Let's look at 26. How is the magnitude of the vector product of two vectors related to the vectors? Okay, well remember, if you've got vector A, vector B, you can put their tails together and determine what this angle is. But in a mathematical sense, the magnitude of the vector product is simply the magnitude of the first vector multiplied by the magnitude of the second multiplied by the sine of the angle between them. Right? So magnitude of A cross B equals the area. Okay, hold on. It equals that, right? So this is just the mathematical side. That's the magnitude. Remember, you still need a direction, because the vector product means when you multiply the two vectors, out comes a vector. Whereas if you recall the scalar product, you multiplied two vectors and out came a scalar value, right? And that's called the dot product or the scalar product. But when you have the cross product, out comes a vector, which means it's got a magnitude and a direction. Okay, so there's the magnitude of the vector product or the cross product. And then graphically, this AB sine theta is equal to this rectangle, okay, given by this. So you've got the magnitude of A, the length of A, then you've got the length of B sine theta right there. And so A multiplied by B sine theta, okay, gives you the area of this rectangle. Okay, let me just see something quickly with the, if you actually go into the textbook, it says the magnitude of the vector product of two vectors is equal to the area of the parallelogram defined by them. So that is the parallelogram defined by them. Okay, so the magnitude is equal to that parallelogram, but it's the same area as this rectangle. Okay, so make sure that you just understand that. Okay, so what's next? 27. What is A dot A cross B equal to? Okay, so pause the video, see if you can try this on your own. Nice question. Very nice multiple choice question as well. Alright, well, we need to understand directions now of the vector product or the cross product. So A cross B gives us some vector, C, but what is the direction of this vector C? What is the direction of that? Well, if you've got A there and B, for example, and you go A cross B, this vector C has to be perpendicular to this plane that these two vectors are in, perpendicular to this plane. So it's perpendicular to both A and B. Okay? I hope that makes sense. Please make sure that you understand. This A cross B is in a plane. Okay? So there's A, for example, and there's B. Go A cross B, and then C is a vector that's perpendicular to that plane. Okay. Now, what if you say A dot? You take that same vector there, and you say dot C. Remember, if you've got A dot a vector C, but that vector is perpendicular, then what do we have? Well, we've got 0, right? So when the dot product, when the two vectors are perpendicular, then the dot product gives us 0, because it's the magnitude well, the scalar product is magnitude of A, magnitude of C, cos theta, and cos of 90 will give us 0. Okay? 28, if you accidentally compute a torque using F cross R, remember, torque, sum of the torques is equal to R cross F. That's important, by the way. R cross F. It's not F cross R. It's R cross F when you're doing the vector product. Okay? It has to be R cross F. So if you compute it saying F cross R rather than R cross F, what is wrong with your result? Okay? You tell me, what is wrong with the result? Well, what is right with the result is that the magnitude will be right. The magnitude of the torque. But the direction will be wrong. It'll be in the opposite direction. So if you use the right-hand rule, so let's do it this way. So now you've got an object, there's the pivot point, and there's your force, and there's the line of action, and you've got this vector R, and so it's going to go in that direction and that direction. So your fingers are going to curl like that, and you get your fingers are going to curl in that direction, and in this case your thumb will come out of the page. But if you say F cross R, then it means that you're going to go F in the direction of F and then curl your fingers in that direction, which means that your thumb will go into the page. So you'll have the right magnitude, but you're going to have the wrong opposite direction.